All right, let's talk about the first component, the power supply. So I'm sure you'll recognize this. This is just your normal, typical plug-in. Then you got your laptop power supply. This is actually my laptop power supply. It's not one that I would use for this particular application because it's too small, but that's the idea. And then that's the DC part right there. So the first component is simply a laptop power supply. And we're gonna get to so we got this done. The PWM, where the magic happens. This is the gizmo that we're gonna start using together. We can adjust the duty cycle on it, and I'll show you guys what this is about, and then the frequencies that we can adjust. We're going to talk briefly about the set and then the on-off if we want to use it. Now, 4 screws, that's all there is to it. DC in is the volt plus and minus, so it's this part right here, so it goes right there, and then the out goes right there. So as you can see already, we plug that into the wall. It's all built for us, and then we cut the wires out of there so we can expose them, so we can terminate them into this, and then out of there we go to our coil. Not much to it, eh? I know. Okay, the coils. Coils, we're gonna make them with magnet wire, speaker wire, whichever way you want to call them. There's different gauges. I like to use either 20 or 22. I'll tell you down the road why I stuck to those 2 sizes, and you'll see there's a lot of math involved, but we'll keep it really simple, and then we'll go from there. And then, so to make the coil, I'm gonna get you guys to get the old trusty propane bottle, and I'm going to show you how we use it. This end right here is round. We're going to wrap it around, and there's an exact number that we need to use because Ohm's law, and depending on the size we're using too. And then we make our coil, and then we're going to use some tape, and we're going to tape it up. See, so far pretty simple. There's another size here. Okay, this guy and this guy, I like to put them in a box. And this is the box that I started using originally, and I cut that into this. See, like there's a lip around this, so I'll show you guys how I make it. And I just cut it, and then it goes inside, and then inside of this I put the power supply. Now once again, we'll talk about that in more detail later on. In a nutshell, right now, we have the machine. I'm going to show you, I'm going to tease you guys. This is a very simple PWM system. This is a 5-volt battery charging unit. I use double-sided tape, stick it to this tiny little box. I got this mounted inside. So there's no 120, so basically this is gone. This is the battery pack, and then the battery pack connect to that, and this is how it connects right there. Okay, now it's on. Now you get to see for the first time what the screen looks like. So we're at 67% duty cycles, and the frequencies is 14. So we can bring the frequency down, 9, 8, 7. We're gonna put it on the oscilloscope. I'll show you guys what it looks like in real life using meters basically. Okay, and then out of there, this wire goes to our coil. And you're gonna say, what the hell is this contraption? Well, I was doing a test. This is a sleeping mask. I love the sleeping mask because I can put it over myself everywhere, around my shoulder, my neck. Take my headache away with it. At first, I glued them on with my glue gun, and they got hot and they melted the glue. So I kind of did a quick stitch on this one. This one's still just glued on. This thing makes a lot of gauze. This little guy. I'm going to show you. Quickly, just teasing you guys here. I like gauze, and we're gonna put the hold on it. This is a Hall probe, by the way. Okay, hold. Put it on the hold so it holds the highest possible value, right? So this little guy right there, and we'll talk about how to measure gauze and stuff like that, and like later on, like how you're supposed to measure it from the center and everything else, and blah blah blah, and three-dimensional, and like it's quite the thing. But just for argument's sake, 65 gauze coming out of each of these little guy right there. If I take the hold off and I lower these frequencies to 1, you're gonna see it pulsing, which is pretty cool. You see it pulsing, on, off, on, off. Do you see the north-south changing? That's where the magic of PEMF happens, by the way, and that's due to a flyback voltage. I'm not trying to get technical here, just telling you the magic in PEMF is that field changes. If we didn't need the field to change and it would work the same, all we would need is a magnet. And there's a magnet. This is a neodymium magnet, and I'm moving like right now. Is this thing on? Okay, it's off. So there's 800 some odd gauze out of this. Let's hold it there across the field at its maximum power. So if changing the field was not that important, all we would need then is a magnet, and there'd be nothing. What a PEMF does, right, is it makes this north-south change at whatever frequencies you put it in. That's it, okay? And that's what we're trying to achieve. Anyway, this is my little portable prototype that I take with me everywhere. This little battery pack gives me about 4 hours on this system. I'm gonna make a new one that is not glued on, and I really enjoy it, so I'm gonna make a good one that I'm gonna take to the mountains with me. Yeah, okay.